So I'm going to start off presenting the Smart Cities bit. My name is Jerry. I live in Norway, but I'm not originally from here, if you can tell by my accent. So we're going to look at the unit which I worked on, which is the energy for tomorrow. And I'm going to dive right into the software. So I'm going to share my screen with you. What I wanted to do with my 5 minutes is basically just sort of go through the software and talk a little bit about some of the tips and tricks in using this. I didn't develop this software. It comes from a public-private partnership in the US called the Concord Consortium. And they have lots of great software there, as well as Energy 3D. So I certainly suggest that you check them out, but I'm going to focus on Energy 3D today. So in using this program with my students and testing out the unit that I created, one of the biggest issues that I had was looking at the computers that my students were using, because I work in a bring your own device type of environment. So we had students with very old computers and students with very new computers. And that can affect how this software plays out because depending upon what you're trying to do, how big of an analysis you're trying to do when you set up a solar field for analysis, if you have students that are working on very old computers, it can take a long time, especially if they're analyzing a very large area. I had one student tell me that she set the computer up overnight, and basically in the morning when she woke up, her software had prepared her analysis, and she was trying to do something that was quite large, and her computer was not top spec. So know your students' hardware before you try this with them. And if you think that the software isn't going to be functional, one of the things that you can do is have them analyze much smaller portions, and you can actually create what you want them to analyze and share that file with them. So up here in the upper left-hand corner in the file section, you can see that there's a Save As button. So what you create here on the build platform, you can save it and then share it with your students as a file. And I've done that before. If I don't want them to spend time actually trying to build something, I can pre-make something that I just want them to focus on the analysis and testing the variables on, and save it and share it to them on our learning platform, and then they open it up directly in here and everything's ready to go, and then they just focus on the analysis portion of it. A couple of other things which I didn't add into the lesson, but I think are worthy of note. Up here, you can add plants into it. It's important when we talk about solar, because obviously shading of solar arrays can be quite problematic. And you can actually change the type of plant that you have here. So by right-clicking on it, you can select the type of tree. And obviously, if you select something like a pine tree down here, it's when the time goes through over the course of a year, when you get into winter months, this pine tree is going to still provide shade to the solar panel array. So that's one interesting environmental factor that you can bring into the software. Another interesting aspect back up here at the view section here is the ground image. Now you can see that the ground around my build platform is just this blank green, but you can actually bring in an image from Google Earth View of your specific area and use that for analysis of what type of solar might be possible in your area. So they can actually build around their own neighborhood. Your students can bring in an image of around their own neighborhood and actually build out from that. So that's quite interesting. And one other thing I'll share with you is that one of the great things about this software is that it actually allows you to construct what you've built. So I'm just going to bring down a simple building here, just like this. And like you can build much more complex shapes, but if you wanted to test solar out on the roofs of houses, you could build a village up. And then by going to this printer icon over here, what it's going to do is take that shape and actually break it down into the individual parts for printing. And then your students can actually build that section. I think I'm out of time. I'm going to turn over to Panagiota now.
I am Panagiotta Argyri. I am from Greece. And in my part for Smart Cities for the Future, we analyze the causes and effects of the phenomenon of air pollution based on research evidence on a global scale. Our aim is to inform people about these burning issues and to propose solutions to the problem. Students and scientists study causes, and as members of community, they are challenged to seek solutions. But how? We based on real data, real statistical data, and graphical representation. And in these next slides, I would like to share with you some examples, some activities. For example, how much does a country emit each year? How is the average emission per person? How much has it emitted over time? How do emissions compare and when we correct for trade? Coal, gas, how much comes for coal, flowing, or commented productions? Carbon and energy efficiency. How much energy do we use per unit of GDP? How much carbon do we emit per unit of energy? In this graphical representation, you could mention and you could ask, how can the emission of carbon dioxide in our country be reduced further? Modern research has shown that a new biofuel made from wood helps reduce carbon dioxide emissions. In fact, companies such Good Fuels or etc. have to decide the action to system management of forest for the production of the first such biofuel. In the next activity, we could mention that Greece is ranked in 51 ranked in the world, while the first place is held by China, followed by the USA, and then India and Russia. A next example, an activity, is to compare, as I referred at the beginning, our country's carbon emissions to consumption based on carbon emission. How have they development? So we have two different graphical representation, and we can see that between 1919 and 2002, compute-based emission increased about 16% and were higher than our emissions. We could compare also in other chronological dates. Between 2002 and 2009, there is a decline and then a return of emissions. There are many different examples and many different statistical graphical representation for investigation and inquiry-based science learning. But what are the solutions? What we have to do? In this online calculator, we could calculate the carbon footprint, such our day way of life has a huge impact of our planet. Day by day, carbon emissions are created by driving cars, eating, cooking, working, celebrating, and finding. So, our students could use this calculator in order to estimate their impact on global warming on a period of 1 year, 12 months. So they select their daily habits, amount of total energy used in their house, any flights, interactives, transportations, food and drink products, computer and IT components. As final result, they could find ideas on how to reduce your carbon footprint. So go to these online links and materials and have good luck in investigation with your students. Thank you so much.
Good evening. I'll speak about air quality. In this part, we talk about what is air pollution more than in the other parts. And at first, what is air quality index? Because every country has another kind of calculation of this index. In the same time, we developed three devices, free analyzers for the air quality. And also the students made the data transfer and data processing through graphs. And I'll show you today which were our goals at first: to measure continuously the concentration of different air pollutants, to send, as I said before, the data in real time, to register all the data on a server, and also to plot in real time the graphs for every measured parameter. And this was the first one of this is the first one device. And here you can see there are many sensors here in the carbon dioxide. There are other sensors in the box, also sound sensor and sensor for temperature. Another sensor, this is for temperature, this is also for pressure, for TVOC. TVOC, it means total volatile organic compounds. Then we can go back to the presentation. The next one is the CaeliBox 2. In this case, it was the heart. It was not an Arduino. It was a Raspberry Pi 4B. And there were other, as you see, other sensors. This box I'll present at the end has particulate matter 1, 2.5, and 10. And the last one is another kind of device. This device cannot transfer the data on the server. It will be done some month later, yes? And we have also developed this platform. This we have this Save Nature, Better Environment, Better Tomorrow. You can put your smartphones on this Scan Me, and you can see all the data on our site. We made some graphs with the data from the tables of the site, and we can compare, for example, here in the middle, the quantity of carbon dioxide in 1 hour in a classroom. You see, at the beginning, the quantity was small, but at the end of the hour, the carbon dioxide rise very much. And there are also some example from the site. And at the end, I want to tell you how is the gain for the students, because the students didn't know many things before we began to work in this project, but I have to tell you that the project was developed not meanwhile the physics lessons. We worked in the afternoons in school or at home and so on. Now I want to share my screen to show you some graphs made today. If you read here, it's in some minutes before the beginning of this transmission, because I put one of CaeliBox, the CaeliBox 2 in function, and only I blow to the sensor of carbon dioxide, and you can see this began to be higher and higher. Yes. And if I made now an reset, okay, you can see the carbon dioxide come back, and now it's 18, 22, there are some minutes delay. Yes, this is our work. I can show you on the camera also another the CaeliBox 3 with all parameters showing here.
Was one question, Corina, how old the students were that are involved in the project?
When I began with them, they were about 16, and now they are 18.
Okay.
But we began much time ago. Yes.
So I can also say some of Corina's students also came to Berlin when we published the materials. And it was really good to see how enthusiastic they are about their work. So I think if you have long-term projects with your students where they get really invested, then from an outside perspective, it seems to make a huge difference.
They were very, very happy every time they put in function one sensor, second one, and so on. They were very happy it's working. Yes, of course.
So thank you very much. Are there any questions for the Smart Cities group? So you've seen now how you can look at the solar energy for cities, how you can compare your own city or country in terms of carbon dioxide and air pollution, and also how you can make actual measurements.